For accessing a VM, the creator of an instance has full root privileges on that instance. On a Linux instance, the creator has SSH capability and can use the Cloud Console to grant SSH capability to other users. On a Windows instance, the creator can use the Cloud Console to generate a username and password. After that, anyone who knows the username and password can connect to the instance using a remote desktop protocol or RDP client. We've listed the required firewall rules for both SSH and RDP here, but you don't need to define these if you're using the default network that we covered in the previous module. For more information on SSH key management and creating passwords for Windows instances, refer to the link section of this video. The lifecycle of a VM is represented by different statuses. We'll cover this lifecycle on a high level, but we recommend returning to this diagram as a reference. When you define all the properties of an instance and click Create, the instance enters the provisioning state. Here, resources such as CPU, memory, and disks are being reserved for your instance, but the instance itself isn't running yet. Next, the instance moves to the staging state, where resources have been acquired and the instance is prepared for launch. Specifically in this state, Compute Engine is adding IP addresses, booting up the system image, and booting up the system. After the instance starts running, it will go through the pre-configured startup scripts and enable SSH or RDP access. Now, you can do several things while your instance is running. For example, you can live migrate your virtual machine to another host in the same zone instead of requiring your instance to be rebooted. This allows Google Cloud to perform maintenance that is integral to keeping the infrastructure protected and reliable without interrupting any of your VMs. While your instance is running, you can also move your VM into a different zone. Take a snapshot of the VM's persistent disk, export the system image, or reconfigure metadata. We'll explore some of these tasks in later labs. Some actions require you to stop your virtual machine. For example, if you want to upgrade your machine by adding more CPU. When an instance enters this state, it will go through the pre-configured shutdown scripts and end in the terminated state. From this state, you can choose to either restart the instance, which would bring it back to its provisioning state, or delete it. You also have the option to reset a VM, which is a similar process to pressing the reset button on your computer. This action wipes the memory contents of the machine and resets the virtual machine to its initial state. The instance remains in the running state through the reset. There are different ways you can change a VM state from running. Some methods involve the Cloud Console and the gcloud command, while others are performed from the OS, such as for reboot and shutdown. It's important to know that if you're restarting, rebooting, stopping, or even deleting an instance, the shutdown process will take about 90 seconds. For a preemptible VM, if the instance does not stop after 30 seconds, Compute Engine sends an ACPI G3 mechanical off signal to the operating system. Remember that when writing shutdown scripts for preemptible VMs. As I mentioned earlier, Compute Engine can live migrate your virtual machine to another host due to a maintenance event to prevent your applications from experiencing disruptions. A VM's availability policy determines how the instance behaves in such an event. The default maintenance behavior for instances is to live migrate, but you can change this behavior to terminate your instance during maintenance events instead. If your VM is terminated due to a crash or other maintenance event, your instance automatically restarts by default, but this can also be changed. These availability policies can be configured both during the instance creation and while the instance is running by configuring the automatic restart and on-host maintenance options. For more information on live migration, refer to the link section of this video. OS updates are part of managing an infrastructure. Let's see how we can manage the updates to a fleet of Windows VMs. When you provision a premium image, there's a cost associated with this image. This cost includes both the usage of the OS, but also the patch management of the OS. Using Google Cloud, we can easily manage the patching of your OSs. Managing patches effectively is a great way to keep your infrastructure up to date and reduce the risk of security vulnerabilities. But without the right tools, patching can be a daunting and labor-intensive process. Use patch management to apply operating system patches across a set of Compute Engine VM instances. Long-running VMs require periodic system updates to protect against defects and vulnerabilities. The OS Patch Management Service has two main components: patch compliance reporting, which reports insights of the patch status of your VM instances across Windows and Linux distributions. Along with the insights, you can also view recommendations for your VM instances. And patch deployment, which automates the operating system and software patch update process. A patch job runs across VM instances and applies patches. There are several tasks that can be performed with patch management. You can create patch approvals. You can select what patches to apply to your system from a full set of updates available for a specific operating system. You can set up flexible scheduling, so you can choose when to run patches, one time or recurring schedules. Apply advanced patch configuration settings. You can customize your patches by adding configurations such as pre and post patching scripts. And you can manage these patch jobs or updates from a centralized location. When a VM is terminated, you do not pay for memory and CPU resources. However, you are charged for any attached disks and reserved IP addresses. In the terminated state, you can perform any of the actions listed here, such as changing the machine type, but you cannot change the image of a stopped VM. Also, not all of the actions listed here require you to stop a virtual machine. For example, VM availability policies can be changed while the VM is running, as discussed previously.